So hello, today I am going to discuss about Doppler effect. So what is Doppler effect? Doppler effect is basically says the change in frequency and wavelength due to the relative velocity of source and the observer. So source and observer এর relative velocity ধরুন যে frequency এবং wavelength এর change দেখা যায় সেটাই this phenomena is very much known as Doppler effect. So key change the change in frequency and wavelength due to what due to the relative velocity of source and the observer. And the observer. So তাহলে this phenomena is held due to the relative velocity of source and observer. So first of all, let's hear a sound. Okay, so these sounds is like that some source is emitting constant frequency and constant wavelength of sound, and let's hear this sound. Like that some source is moving towards me first of all, and then it moves away from me. Orthat what's me? Now here I am the observer, and something, any source is coming from me, and then it move away. So in this phenomena is held, or this phenomena is occurred due to this relative velocity. Here we discuss about three cases of Doppler effect. What are the three cases? The three cases when observer at rest and source is moving, and second, the when source is at rest and observer is moving, and third, when both source and observer both are moving. Now I am going to discuss about these three cases when the source is moving and observer is rest. So here it is a source. The source is denoted by O. The source is denoted by S. So it's emitting some wavelength. Okay, it's emitting some wavelength. So let's assume the wavefront of the source is a spherical. Let's assume that the wavefront of the source is spherical. So now, so this is the source is when it is at rest. So its initial velocity v is equals to 0. So it is at rest, so v equals to 0. Then the wavefront is just like this, spherical. So the wavefront is become just like this, v equals to 0. Okay, now the source is moving with some velocity v which is not equals to 0. Then what happened? We now see. So this is the source S, and its wavefront is now like that. Now, when the source is moving with velocity v, then the wavefront is become like this. And when the velocity of the source is 0, then the wavefront of the source is like this. So, when velocity is 0, then the source is emitting, so wavelength of the source when it is at rest is lambda. Okay, now let's assume the wavelength of the source is lambda when it is at rest, and the wave and the velocity and its velocity c and frequency n. Okay, so now we let's take it the frequency n and the velocity c and the wavelength of the source is lambda. So now we can write it as c equals to n lambda. So n equals to c by lambda. Okay, so c equals to n lambda, n equals to c by lambda. Okay, so when the source is at rest, then its frequency is n, which is c by lambda. And when the source is moving, so now here are our observer. Okay, so this is a very cute observer. Okay, now the wavefront is come closer to each other due to the velocity of the source. As the wavefront are closer to each other, so here the wavelength lambda is must be affected. Okay, because when here at some particular time t, the wavelength produces, the new wavefront produces, but here the time is decreases. Okay, here the time between two wavefront is decreases. That's why the wavelength of the source, the with respect to the observer, the wavelength of the source with respect to the observer is changed. So now the changed wavelength, it's, let's assume lambda dash. So now the change wavelength is lambda dash, which is equals to c by n minus v by n. Okay, so what is the n? N is when the observer when the source is at rest, then the frequency of the source is n, and then the velocity of the wave is c. So now the lambda dash equals to c minus v by n. So it is c minus v by n. Okay, now so how can we write it now? Now the new wavelength n dash, what is n dash? N dash is equals to the frequency of the source with respect to this cute observer. Okay, now the frequency of the source with respect to observer is equals to the velocity of the wave is fixed. So the frequency of the wave is with respect to the observer n dash equals to c by lambda dash. Okay, c by lambda dash. Here lambda dash equals to c minus v by n. So now substitute this lambda dash in this equation. How can we write? We can write it as just like this. So n c by c minus v. So here n dash equals to n into c by c minus v. Okay, now it is hence proved. Okay, so here are a minor mistake. So this is not source. When source is moving and observer is at rest, and it is moving towards the observer, then the frequency of the source of with respect to the observer is n dash nc minus v. And when it is moving away from the observer, then the wavefront of the source is become like that. So here the source is moving away from the observer. Here the source is moving away from the observer. And here the our acute observer, so it is at rest. V of observer equals to 0, and the V of S, so it is V, only V. So this is the V, and the V observer is rest, and the source is moving away from the observer. It is moving towards from the observer. Then in this case the frequency is this, and when this is away from the observer, the velocity is added. So the n dash equals to nc by c by c plus v. Okay, so when it is away from the observer, so when it is away from the observer, then it is n dash equals to n into c by c plus v. And when the source is moving towards the observer and the observer is at rest, then the frequency is n into c by c minus v. Here the frequency increase and here the frequency decrease. Here the frequency is decrease. So this is the all case. So this is the all case when the source is moving and the observer is at rest. So now let's move on the second case where the source is where the observer, case number 2, the observer is moving and source at rest. When the observer, this is the case number 2 where the observer is moving and the source is at rest. So when this is our again this is our the acute observer. So now the observer is moving with velocity v naught. Okay, now the observer is moving with the velocity v naught. Now then as usual, frequency of the source is n, wave এটা কি frequency, velocity of the wave and lambda wavelength. lambda হচ্ছে wavelength. Now as তাহলে here the wavefront is spherical. As the observer is raised or moving, the wavelength of the source is wavelength of the emitting source, wavelength of the source is same as it is just like the previous ones, the wavefront is spherical. So here the velocity of the wave is affected, because when any observer moving towards the source, then the frequency of the source is increased. Okay, the frequency of the source is increased. Now the n dash is the frequency of source with respect to observer n dash equals to c plus v by lambda. So n dash equals to c plus v by lambda. So in this case also, when the velocity, so this is v naught, so this is v naught is the velocity of the observer. So v naught is the velocity of the observer. Now here as the velocity of the observer increase, the frequency of the source with respect to observer, this is the observer O, the frequency of the source with respect to observer increase, and when it move away from the observer v naught, when it move away from the observer, then the frequency of the source with respect to the observer is c minus v naught by lambda. So it is when observer moving away from the source, when the observer is moving away from the source, then the frequency index equals to c minus v naught by lambda, and when the observer is moving towards, index equals to c plus v naught by lambda, when moving towards the source. When so it is a third case where I am going to discuss about when the source and the observer both are moving with respect to each other. Here, as the source is moving, so the wavelength with respect to the observer is changed, and as here the observer is also moving, so the velocity of the wave with respect to the observer is changed. So here this is the source S, and as it is moving with some velocity which is denoted by Vs, and as usual its wave front, the wavefront of the sound which it is emitting, it's spherical, and as it is moving it is just like that. So and its velocity is vs. Okay, and here this is our again this is our again cute observer which is moving towards the source at some velocity with some velocity v naught. So as the source is moving with velocity vs, so the wavelength of the wave with respect to the observer is denoted by lambda dash. Okay, so the wavelength with respect to the observer is lambda dash. So lambda dash is now c by n minus vs by n, where the n is the frequency of the wave. So what is n? The n is the frequency of the wave, and the what is lambda? This lambda dash the wavelength with respect to observer, and the frequency n which is equals to n dash which is equals to c plus v naught divided by v naught by v naught by lambda dash, and here the lambda dash is c plus v naught divided by c minus vs into n. So when the source and observer both are moving with respect to each other and both are moving towards with respect to each other, then the frequency change like that. Then the frequency is changed like that. So lam n dash equals to n into c plus v naught divided by c minus vs, where vs is the velocity of the source and v naught is the velocity of the observer. So as they come closer, as the velocity of both are increase, so it's some change. Okay, and now let's assume that the observer and the source is moving opposite to each other. Then what happened? Let's discuss about this. So it is when moving towards. Okay. Now it is going velocity vs. This is our observer. This is our source and this is our observer. So then this is Vs. So now the n dash equals to n into C minus V naught. C minus, this is V naught, not Vs. This is V naught and this is Vs. So as the V naught, as the observer, this is our observer and this is our source. So as the observer and the source is moving opposite to each other, then the frequency change is like this. Okay, the change in frequency happen with like this. That's why when when the train is moving away from me, and I I or you as an observer is also run opposite to the train, so the frequency of the sound of the train's horn is decreasing very fast. This phenomena is occurred due to this Doppler effect. So this is the Doppler effect. Okay, তাহলে it is when both are moving away from each other. So it is when both are moving away from each other, then the frequency change of frequency is like that, and when both are moving towards each other, then the change of frequency with respect to observer is like that. So here the video is end. That's all. This is the first part of the video. Here I am discuss about the Doppler effect for sound. Okay, so this is part 1. Okay, this is the part 1 where I am discuss about sound. And if you guys give so many love and like and comment, then I will share I will come its second part of the video where I am discuss about some problems, advanced problems on the Doppler effect, and the so part 2 problem, okay, advanced question, and part 3 I am discuss about the Doppler effect for light. Okay, and the part 4 Doppler effect for light, part 4 I am discuss about its question, advanced question. Okay, so like, comment and share now.